I wish I had a pause, because what I'm going to do is I'm going to go through a routine here of showing you the output of this battery charger. It's like a fart, wasn't it? This is on the 2 amp setting. This is what the output of the battery charger looks like. We are at 3.7 volts RMS. I will go to 15 amps. We are now at 6.7 or 8 volts RMS. And this is what our output looks like. You'll notice that the duration is slightly longer. This is 50 amps, which again, the duration is getting a little bit longer. And 50 amps, it's showing 11.6 or 11.7 volts. Okay. This is the biggie, 225 amp start cycle. And what do we get? Basically a square wave. Quite a bit like a pulse width modulator. So, how does that compare to the output of a car? That was the big question a few weeks ago when I made several videos wanting to know how to test my cells. And what I think it comes down to here is a nice clean sign. Just hang on a second here, I'm going to start my car up. Well, there you go, folks. That is the output that your generator would see. 14.1 volts, straight, perfectly straight DC. I'm going to go shut this car off. Oh gee, I don't know what you can see here because I got to point the camera at me here. But okay, why? This is my question to everyone, and I hope you'll put it in the comments. Why is it that when we use a battery charger as compared to a straight voltage off of a DC battery, that we get such great results? I don't know, I guess it's kind of a moot point, but in the end, we're probably all going to be using pulse width modulators anyhow, right? So maybe that's how we ought to be testing our cells. Testing them with a pulse width modulator. I mean, ultimately, I think that's how I want to run my cells. Okay, well, this is Bob Campbell. I'll talk to you later.